So the first question was, can we do some of those problems like the last page of the practice test, where it's talking about the relationship between a sequence and series? And so let's do that. So let me kind of give an overview of that stuff, and then we'll go through a page of problems like that. So whenever you're talking about a series, so like if you've got the series, the sum k equals, say, 0 to infinity of 1/2 to the k. There's actually two different things going on there. You've got a sequence 1/2 to the k, or 1/2 to the n, and a corresponding series, which is a sequence of partial sums. So in this case, you've got an is 1/2 to the n, and then you've got the sequence of partial sums, Sn, which is the sum k equals 0 to n of 1/2 to the k. And so Sn always stands for the sum from wherever you're starting until n rather than infinity. And so like when you're looking at this, we've got over here, a0 is 1, a1 is 1/2, a2 is 1/4, a3 is 1/8, and so on. And then over here, you've got S0 is 1. S1 is the sum from 0 to 1, so it's 1 plus 1/2. It's like if you plug in 0, plug in 1, and add them up. So you get 1 plus 1/2, which is 1.5, and S2 is 1 plus 1/2 plus 1/4, which is 1 3/4, and then S3 is 1 plus 1/2 plus 1/4 plus 1/8. You're adding the terms from the sequence that I've got on the left-hand side of the screen. And so there are two things going on here. You've got this sequence 1, 1/2, 1/4, 1/8, and so on. And then you've got this series or sequence of partial sums, 1, 1.5, 1 3/4, 1 7/8, and so on. And so we've covered two big types of proofs, or two big types of problems, where we're showing whether a sequence or a series converges or diverges. So the first stuff we did was dealing with these. So like we might have done a proof that 1/2 to the n, we would say, okay, that converges to 0 because it's an exponential where the base is less than 1. This is not a geometric, the one on the left is not a geometric series, it's a geometric sequence. We know that goes to 0. So we have all these techniques like squeeze theorem, or like just looking at the biggest thing over the biggest thing, or maybe looking at the absolute value. These are before the series test that show whether this list of numbers converges or not. Then we have all these series tests like geometric series and p-series and integral tests and all of those, so comparison tests, alternating series tests, that tell you what the series does. So like our proof here would be, okay, this is geometric. The absolute value of r is 1/2, which is less than 1, so the series converges. When we say that this series converges, we mean this list of numbers over here is converging. So when the series converges, that means the sequence of partial sums converges. This is one where we can find the sum. The sum is a over 1 minus r for a geometric series. Man, that does not look like an a, but the sum is a over 1 minus r for geometric series. So in this case, that's 1 over 1 minus 1/2, which works out to be 2. And that's telling you this sequence goes to 2, which is pretty clear on this problem, but in general is not clear when you're just listing numbers. It's clear from the proofs. And so you've always got these two different things going on. You've got the sequence and the corresponding series. And so then the page that Nick was asking, I think it was Nick or Dominic, one of you guys was asking about, was that last page in the practice test that's getting at the relationship between these two. And so there's a few different things that are weird, but the most direct relationship between the two is the k-term test, or the test for divergence. And what it says is if the limit of the sequence, okay, the limit as k goes to infinity of ak does not go to 0, then the corresponding series ak diverges. And so if the sequence on the left did not go to 0, then the sum would have to diverge. And the easiest way to think about that is, like, let's say instead of converging to 0, let's say this converges to like 0.1. And so then if you add 0.1 plus 0.1 plus 0.1 forever, then that goes to infinity. And so the idea is if this doesn't go to 0, then this would have to diverge. There's more rationale behind it than that, but that's an easy way to think about it. Okay, and so the page that we've got is talking about that relationship. So if the sequence does not go to 0, then the series, so this is the sequence over here, and we'll maybe write this in green. This is the sequence. Then the series diverges. Okay, but equivalent to that, so an equivalent statement is that if the sum converges, so if the series, man, sorry, it's not very neat. So if the series converges, then what do you think we would know about the limit of the sequence? So based on logically here what we know, then if this is true, then what would the sequence have to do?
Go to 0.
It would have to go to 0. And the reason we know that is because if it did not, then this series would have diverged. And so what I'm writing in green, we don't present as a separate result, but that has to be true based on the K-term test. And yeah, you guys, I see any of the handouts you guys need, I'm happy to give you if you're in a different class, just right after. Sorry, I've seen that. Thanks for helping each other out. But I'm happy to send them to you right after this too. So anyway, so the idea is, okay, well, if the series converges, then this couldn't have been true. So then the limit of the sequence would have to have been 0, because if it weren't, then the series would have diverged. And so if we know the series converges, the limit of the sequence is 0. And so you have to keep track of those two. So, all right, so there's two main types of problems on that page. And so let's look at that page and go through the ones that kind of make sense from what we were just saying. So this is from an exam a few years ago. And so, okay, so the ones down at the bottom are kind of what we're getting at. So this page, just so you guys know, this is at the end of a lot of the old exams. This is on the fall 2017 one, which I don't think you guys have, but I'm happy to send to you. It's just, you know, I think I gave you guys 2 years of old exams. Maybe you have this one, I'm not sure. But anyway, so this page says that if there's enough information to determine the answer, provide it. If there's not, write not enough information, and you don't need to explain. Okay, so these at the bottom, when we're talking about sigma of BK, so remember, like, the thing inside BK is the sequence, but sigma BK is the series. So what 17 is telling you is that the series goes to 1.001. So the series converges. What does that tell you about the sequence BK?
Would it go to 0?
It would have to go to 0 because of what we were just saying. Because if it didn't, this would diverge. And so what's significant about this problem is not that it's like bigger than 1. That's a little bit misleading. So it's not that it's bigger than 1. It's that it is a number. So the fact that it goes to a number at all means the sequence has to converge to 0. Now, if the series diverges, then we don't know what the sequence does, because you can have So you don't need to explain on this, but you can have a sequence like, let's say CK is 1 over K. Well, then the sum of CK does diverge. But what is the limit of CK as a sequence in that case? What do you guys think?
Zero.
So yeah, it's 0. Okay, but also if CK were, say, 7, then okay, the sum of 7 plus 7 plus 7 plus 7 forever clearly diverges, right? But what's the limit of CK in that case? 7. And so we don't know what happens. CK could go to 0. It could go to something else. It could diverge. If we know that the series diverges, that doesn't tell us what the sequence does. So if we go back and look at this kind of logic at the bottom, these are the exact two things we do know. We do not know modifications of this statement. So if the sequence does not go to 0, then the series diverges. If the sequence does go to 0, we don't know what happens with the series. And then same down here. If the series, if what we know is that the series converges, then we know the sequence goes to 0. But if we know the series diverges, there is no conclusion here. Does that make sense to everybody? Everybody clear? So these are the exact two things we know from the K-term test, or test for divergence, if you've been calling it that, either way. Okay, so then if we go back to here, now, okay, on number 19, I'm telling you, okay, well, the limit of dk is 0.9998. So dk, is that the sequence or the series on number 19? Is that the sequence? Yeah, that's the sequence. So the sequence goes to 0.9998. So then if we know that, what does the series do? What do you guys think?
It diverges.
Yeah, it diverges. And the reason why it diverges is because that limit of the sequence is not 0. Does that make sense to everybody? Okay, so the limit of the sequence, because it's not 0, then the series must diverge. Now on 20, I'm telling you the limit of the sequence is 0. So what does that tell you about the series? It does not tell you anything, because it could converge. So like if GK was 1 over K squared, then the sum 1 over K squared converges. But if GK was 1 over K, then the sum 1 over K diverges. So the sum could converge or diverge, and we don't know in that case. Do these 4 make sense to everybody? It's very easy to get confused on them. So please ask if something's not clear.
So like on number 20,
Yep.
that was like flipped backwards where it said if the sum converges, then we would know that the limit goes to 0.
Correct. And that's
So
like,
it's just like so it's just like, since it says if we know that, we don't know. Since it's like backwards.
yes, I think. But like I said, it's very easy to get backwards. I'm not 100% sure you're saying it right. But if we said if the sum BK or if the sum GK converges, we don't have to give a number. So if this had said converges, which is what I think you're asking, what is the limit of BK? And then that would be 0. Is that what you meant?
Yeah, no, that's what I meant.
I think that's what you said, and you're right. Okay, other questions on that part?
For number 19 and 20, this is probably a stupid question, but if it says if it converges, what is its sum? Is that just what it converges to?
Yes, yes.
Okay.
So what a sequence converges to is called its limit. So a sequence converges to its limit. A series converges to its sum, because it's like what you get when you add them all up. Does that make sense?
Yeah.
Okay, no problem. And you could probably call it a limit too. It's just standard to call it a sum for a series. Okay. All right. Other questions? Yeah. Can I explain 20 again? Yeah. So the idea on 20 is that so what we know from the K-term test is if the sequence does not go to 0, then we know the series diverges. Unfortunately, if the sequence does go to 0, we don't know. And one of the reasons why we don't know is if you look at these two. So if GK is 1 over K squared, then 1 over K squared as a sequence goes to 0. But the sum 1 over K squared converges because it's a P series where P is bigger than 1. Then if GK is 1 over K as a sequence, that sequence goes to 0 because it's 1 over infinity, but the sum diverges because it's harmonic. So we have two different examples over there where this part's true. The limit of GK is 0, but one of them converges and one of them diverges, which means in general, we don't know. So you could have a sequence that goes to 0 and then the series could converge, or it might diverge. It just depends. Does that answer the question in chat about that? Okay. All right. Any other questions on these four? Because these are for sure confusing. So it's okay. And it's okay if later you're still confused about them and you think about it again and you ask a question again, that's fine. If you're repeating the same questions, completely fine. All right. Now, back up on these. If I'm looking, let's go back over here. If I'm looking at normal problems, okay, so most series problems, the formula that is right here, the formula that you are given, is that formula for AK or AN, or is it for SN? So is this formula, 1/2 to the K, is that a formula for the sequence, or is that a formula for the series?
Series?
The sum is the series. But if I plug something right into here, if I like plug 4 into there, that's giving me the fourth term over here. You see what I'm saying? Like 1/2 to the fourth is the fourth term in the sequence, or A4. S4, you'd have to add up from 0 to whatever. And so like this is not a direct formula for the partial sums. It is a direct formula for the sequence. So most of the time, the formula you've got is actually for the sequence, not the series. The sigma says you're adding up this other sequence. So if I asked you in this case to find A27 and S27, which of those is easy from this notation?
A27?
A27, because it's 1/2 to the 27th. And I'll let you figure out what that is, but 1/2 to the 27th. S27 is annoying. It's 1 plus 1/2 plus 1/4 plus up until plus 1/2 to the 27th. You have to add up a bunch of stuff. It's not that you can't do it, but it's not a very easy direct way to do that. And so when I look at a series like this, something there clearly converges to 3/4. What converges to 3/4? The series or the sequence?
The sequence.
The sequence converges to 3/4, which means the series does what? If the sequence, yeah. So because the sequence converges to 3/4, the series diverges. So, okay, real quick, in this problem, if I asked you to find A3 and S3, how would you find each of those? How do you find A3 on this problem? What do I do? Or actually, which one of these do I just plug in 3?
A3.
A3. So A3 is 3 times 3 minus 5 over 4 times 3 plus 7. S3 is A0 plus A1 plus A2 plus A3, which means I've got to go find all of them and add them up. Now, that is the normal setup. Okay, the normal setup is you're given a formula for the sequence. That's why you have all those tests, like the ratio test, the root test, alternating series test, comparison test, all of those tests. The reason those are weird is because you don't have a formula for SN. And so you can't use normal limit stuff because we don't have a formula for this. So what those first 4 questions on that test are asking is it's giving you this instead. It's saying for some series, you've got Sn equals the sum, and we'll do K equals 1. I don't know what it says on the sheet. it's different depending on the test, equals this, equals 2n minus 5 over, say, 3n plus 1. Okay, so it says you're given that. Now, read carefully what that formula is. This 2n minus 5 over 3n plus 1, is this statement telling you that that is the sequence or that's the partial sum?
It's the partial sum.
That's the partial sum. And so that's what's weird about this one. So something converges to 2/3. What converges to 2/3 here? The sequence or the series?
The series.
The series converges to 2/3. So the series, any question asking about the series, that goes to 2/3. There are several different notations for that, but here the series goes to 2/3. Because the series goes to 2/3, what does the sequence then have to do?
Diverge.
Not diverge, it's okay.
Zero.
Has to go to 0 because of this. Because if the series converges, the sequence goes 0. Completely fine that we answered that wrong at first, but do we see why this is right? Does that make sense? It is very confusing. And remember over here, the sequence is going to 3/4, so the series diverges. That's the first version of the K-term test. This is the second version of the K-term test. Now, again over here, what if I'm asking now for A4 versus S4? Which of those? So over here, the one you just plug in is A3. So A3 means you just plug it in. Given that this formula is for Sn, which one of these do you just plug in for?
Sn?
Sn. So we do S4. S4 is 2 times 4 minus 5 over 3 times 4 plus 1, whatever that is. So 8 and 3 over 13, I think. I don't care if you can subtract. Well, I'd like you to be able to subtract. But the point is not being able to subtract. The point is being able to knowing to do that. Does that make sense to everybody? Now, A4. So over here, A3 is easy. S3 is hard. Over here, S4 is easy because you've got the formula for that. A4 is hard. We can get A4, but the way we get it is we take S4 and we subtract something. So S4 would be the sum from 1 to 4. So S4 is A1, A2, A3, and A4. Right? All added up because this one starts at 1. So what could I subtract from that to get just A4?
We subtract A1, A2, and A3, like the sum of that.
Yeah, I want to subtract the sum A1, A2, and A3. But how can I use this to get the sum of A1, A2, and A3?
Wouldn't you just plug in 3?
Yeah, because S3 is the sum of those. So I want to subtract S3 because that's the sum of A1, A2, and A3. So if I subtract those, I get the answer. So then, okay, S4 is 3 over 13, apparently, if I subtracted right down here. And then S3 is what, 6 minus 5, so 1 over 10. And then if you want to get a common denominator, fine. But the point is, you need to show me you know how to do it, that it's S4 minus S3, and that you know that the way I get S4 is to plug it in. I don't care if you subtract fractions. Does that make sense? Everybody clear so far? Okay, so let's go back and look at these. So here, remember it starts at 0. I'm going to give you guys a minute or two and actually try 12 through 15. So see if you guys can try those and then check them with me in just a minute. All right, this is different numbers than what I just had on that other screen, but remember this is SN, not AK. Okay, so this is telling you about the series, not the sequence. Okay, so let's talk about them just because of time. So on this, 4n plus 1 over 3n minus 1, that's the series. So, or that's this partial sum. So something goes to 4/3 from looking at that. What goes to 4/3, the sequence or the series? What do you guys think? So the series converges to 4/3. So that's number 13. So that series converges to 4/3. Now, because the series converges at all, then this sequence must converge to 0. Because if it did not, the series would have diverged. Does that make sense to everybody?
I have a question on 13.
Sure.
It says it changes from k equals 0 to k equals 1. Does that affect the answer?
That is likely just a typo on my part. Man, it does affect the answer though. So, okay, it's for sure a typo on my part. When I gave this test, I'm sure I just told everybody, let's change that to 0. It does not change whether it converges or not. It would change the sum. So the sum from 0 to infinity would go to 4/3. The sum from 1 to infinity would actually go to that minus S0. So it'd be 4/3 minus 1 over -1, which is 7/3. So this would actually converge to 7/3. That was definitely not my intent. That was a typo. But do you see why? Like, so you would lose the A0 term, but A0 is the same as S0. So you would subtract that. That was not the intent of the problem. I meant for it to converge to 0. So let's actually just change it to 0. Oops. Let's change it to 0 and then we're good. Okay. Other question, that is a good comment. That's a good question. Okay. On the next one, 14, I've got it covered up. We want to find A3 plus A4 plus A5 plus A6. So, okay, we're going to use S6. And S6 gives me the sum from 0 to 6. And we want to get rid of S2 because that gives me the sum from 0 to 2. So the idea is S6 is A0, A1, A2, A3, A4, A5, and A6. And we want to get rid of those 3, which is S2, A0, A1, A2. So S0 minus S6, or I'm sorry, S6 minus S2. S6 is 25 over 17. S2 is what, 9 over 5, and then that's good enough. So if you do have this on the test tomorrow, you should say, okay, it's S6 minus S2, and you should show you know how to get those, but that you know to find S6, you just plug it in, but I don't care if you combine those. All right, and then A1 is going to be S1 minus S0, and that's 5 over 2 minus 1 over -1, and then that's 7/2, but you don't have to simplify. All right, does that make sense to everybody? Okay, any questions on that?
This type of stuff only applies to these problems, right? Because before didn't, like, if it went to 4/3 according to the K-term test, wouldn't it diverge, right?
Yeah, and that's the idea back over here that we're talking about, that here, this is the normal case. So if this had gone to 4/3, then the sequence goes to 4/3, therefore the series diverges by the K-term test. This is the weird scenario where that formula is not for the sequence. Does that make sense? So yes, what you're saying is it only applies in this scenario, yes. Does that make sense?
Yeah, that makes sense. Thank you.
Okay, yeah, no problem. Other questions on this, you guys? How do you know to use S to find those sums? Okay, Colin, because when we're doing those, that's the only thing we have access to. So we don't have a formula for AK. So if I want to find A3, A4, A5, A6, I start with S6 because that's what I'm able to find. What S6 means is I go from 0 to 6. So that's A0 up to A6. But the way I find S6 is plugging 6 into here. And then I want to get rid of certain ones. And actually it's the same, correct. This only, yeah, my bad. It was Emily asking that stuff. So yes, this only applies when we don't know AK. I mean, it technically applies always, but you only would use this when you know SN rather than AK. Does that make sense? Yeah, okay, cool. And so that is what's so weird about these 4 problems. What you know is SN rather than AK. All right, and so the other question that I had at the beginning of the chat is, can we do one where we have to find a formula? And actually this number 16 is one where part of this is you have to find a formula. So this one tells you it's find the sum, or it tells you it's convergent, and it wants you to find the sum of the series. And so this is a geometric series. And the reason we know that is because to go from 8 to -4, you divide by -2, but that's the same thing as multiplying by -1/2. And then to go from -4 to 2, you also multiply by -1/2. And then times -1/2 is -1. Times -1/2 is +1/2. Times -1/2 is -1/4. And I think the easiest way to write this series is as the sum k equals 0 to infinity of 8 times the common ratio -1/2 to the k. And it's because like this is A0, this is A1, this is A2, and A3. And so you're thinking, okay, well, at A0, you don't multiply at all. So you want a power of 0. To get to A1, you've multiplied once, so you want a power of 1. To get to A2, you've multiplied twice, so you square it. And so this is the sigma notation for that formula. I think somebody way up at the top asked me, could we do one where we write a formula for a sequence? This is sort of that. Does that make sense, how to do this one? Okay, and so then, yeah, we can do an arithmetic one in just a minute. And so if we're going to find the sum of this, well, we know it converges already. So it's a over 1 minus r. Remember that a is what you get when you plug in 0. So it's 8. And then 1 minus -1/2. So that's 8 over 3/2. That's 8 times 2/3, which is 16/3. And so this one did say to simplify the answer. And so the sum there is 16/3. All right, so we're going to do an arithmetic one next, but any questions on this page? So this is from an old exam from, I guess, 3 years ago. If you have that practice test I gave you guys, or if you're not in my class and you would like that practice, I'm happy to send it to you. And yeah, we'll get, I'm getting a couple more in chat. We'll get to arithmetic next, and then we'll get to the one about factorial using the ratio test after that. But there's a sheet of these in that practice test. Also, if you go back and find the old exams that I've given you, there's probably a page of these on either exam 3 or exam 4, just depending on where we were in the semester. And you have the answers to those, so you can check yourself. So I purposely didn't do the one that you've got. I think this is different from that, so you could go and check them. But if there's one on there you're not clear on, definitely let me know. I'm happy to talk about it. But now see if it makes more sense if you go try them now. All right, any other questions related to this page before we move on? Yes, good. Okay. All right, so then the question is, can we do one where it's arithmetic? So geometric is when you multiply by the same thing every time. Arithmetic is when you add the same thing every time. So find a formula for, let's say, 12, 10, 8, 6, 4, 2, 0, -2, -4, and so on. So, okay, so this is an example of an arithmetic sequence because you add the same thing every time. Or well, here I guess you're subtracting 2, but adding -2 is also the case. And so then this is A0. If we make that A0, then this is A1, this is A2, this is A3. And so you want to think, okay, well, you add -2 a bunch of times. So AN is 12 plus -2N, where N represents the number of times you have added -2. So to get to A0, you don't add it at all. To get to A1, you've added once. To get to A2, you've added it twice. And so, to neaten it up, we might say 12 minus 2n, but these would work. And this would be for n greater than or equal to 0. Does that make sense? You guys good? Okay. Okay. And so that's the arithmetic one. And then, okay, could we do the sum from 1 to infinity of n factorial over n to the n using the ratio test? Yeah. All right, so if we do this, then we've got the limit as n goes, so ratio test, so the question in the chat, I think it was just sent to me, but it says, could you do the sum from 1 to infinity of n factorial over n to the n using the ratio test? So we were told to use the ratio test here. So ratio test is a sub n plus 1 divided by an. We're looking at the limit of that. Here, everything's positive, so we can drop the absolute values. And we get n plus 1 factorial over n plus 1 to the n plus 1 times n to the n over n factorial. And now we're going to try to split stuff up. N plus 1 factorial can be written as n plus 1 times n factorial. And then we'll talk about these in a minute. Okay, any questions to there? Sorry guys, hang on, got one thing I gotta do. All right, any questions to there? You guys good? Okay, so we can get the n factorials to cancel. And then we can cancel the n plus 1 on top with one of the n plus 1s on bottom. So we get the limit as n approaches infinity of n to the n over n plus 1 to the n. And man, that limit is going to be, oh no, I'm sorry, it's not. Okay, so this is then the limit as n goes to infinity of n over n plus 1 to the n. Does that make sense to everybody? Everybody good? Okay, no. What part does not make sense? So we said no, it doesn't make sense.
So did you break up that bottom part and then cancel out the n plus 1 on top and the n plus 1 on bottom? Is that how you got rid of that?
Okay, yeah. Let me show that. Yep. So what I did is I did n plus 1 over n plus 1. I should have just written it that way. Let's do that. Because it's going to cancel with 1 on top. You see what I'm saying? So it's n plus 1 to the n, and then n plus 1 to the first. And now those cancel. That's easier. My bad.
And how did you pull out that n factorial on top? Like, could you just explain that?
So yeah, when you're doing factorials, I think it's actually easier to see when it's something bigger. So if you had like 3n plus 5 factorial, and you're trying to cancel with, say, or let's make that a little bit smaller. Let's say 3n plus 3 factorial, and then 3n minus 2 factorial. Then like you can always take the bigger one and get it to cancel with the smaller one. And the way you do that is you start with the biggest number, so 3n plus 3, and then you keep subtracting 1 until you get to the smaller one. So like if I subtract 1, I get 3n plus 2, If I subtract 1 again, I get 3n plus 1, and then 3n, and then 3n minus 1, and then 3n minus 2. But I stop there because that's what I'm trying to cancel with.
Yeah.
And then it cancels out. So it's weirder when it's this fast, but like n plus 1 factorial, 1 less than that is n factorial. So I just go ahead and stop because it cancels.
So that's essentially n plus 0 factorial.
Correct.
Okay.
Yeah. Does that make sense, you guys? Somebody asked, do we have to write limit every time? You either need to do that or you need to use arrows. Okay. So either do that or use arrows. Okay. This problem is now a L'Hopital's rule problem because it's the form 1 to the infinity. Does that make sense? I am going to wait on completing this until the end of the review because I think for most of us, most instructors, it's probably not something this complicated with L'Hopital's rule in the exam. But if you remember from Calc 1, there are ones where you have to take the log, like you let y equal this and then take the log of both sides. That is what you do to evaluate this limit. I am 99% certain that you get something then less than 1. So this converges absolutely by the ratio test. But I want to make sure I get to everything else before I go through L'Hopital's rule on this problem. But does that make sense? Will you have, okay, yeah. And then the person who asked that, does that answer the majority of what we're doing? I think it was Kaylee, yeah. Yeah, no problem. And then if you have an idea of how to do the L'Hopital's rule, I'm not writing all the versions of the test, so I can't promise you won't have one that complicated with L'Hopital's rule, but my guess is most of us probably would not have one that complicated with L'Hopital's rule as part of the exam, but that is what you would do. Euler's number, you just like E, Andy, would you have to be able to do that? Yeah, maybe. You need to know that E is like 2.71828. You don't need to like calculate, but like knowing that E is smaller than 3 and bigger than 2 would be enough to make a comparison as to which one's the biggest one. Does that make sense? Does that answer the question of the person asking about Euler's number? All right. Okay, cool. Other questions? And like I said, I'm happy to do this. I just don't want to spend 15 minutes on L'Hopital's rule if it's not super, super relevant. Now that I say that, whoever is asking will have that twice on their exam, but I don't think that'll be the case. All right, other questions, you guys? You can unmute yourself or you can type something in chat. Yeah, we can do one with an integral test. So, okay, so Andrew's asking, will we be told to use the integral test? You might not be, but most problems you're not required to use the integral test. So like this is a problem where you would not want to use the integral test unless you were told to. Does that make sense? So it's pretty rare that you need to use the integral test. There's like a couple examples. If you look at the series 3 handout, the last 2 are ones where I think probably the best method is integral test, but that's rare. The best method is integral test. Does that make sense? Okay. All right. So like I'm telling you here because you would not want to. So like, okay, if you guys do look at this, we should be getting to the point now where you should be able to look at that pretty quickly and know what this does. In general, you will not be told what test to use. So somebody's asking in chat, will you be told which test to use? Generally, no. There may be one that says use the integral test because we want you to show how to use the integral test, but in general, you need to be able to pick out the test. Okay, so like this one though, this series would diverge. How do I know ahead of time that it's going to diverge?
It's harmonic.
Well, you would compare it to the harmonic series. And so once you, so there are good strategies to figure out what test to use. So somebody's asking in the chat, are there easy ways to figure that out? I don't know that they're easy, but there's good strategies for that. And so maybe we can talk a little bit about that next. It's not like cut and dry. It's like integrals, like sometimes there's exceptions, but yeah, there are good strategies for that. But anyway, this one's one where you would compare to k over k squared, which is 1 over k. That diverges, so then this diverges by limit comparison test. That's what you should do for this problem, which is why I'm saying use the integral test, just because somebody told me, hey, can we do an integral test problem? So, okay, so if you're going to use the integral test, so knowing that it diverges helps because we know whether we're doing it right. When you're doing the integral test, you say, okay, let f of x basically equal whatever this sequence is except with x in it. Sorry, I'm doing chat. Adam Gudikins is holding a review session. And if you wait until the end of mine, I will let you guys know when that is and the Zoom information. Let me make sure it's open to everybody. It might only be open to his students. Lauren, are you in my class or are you in somebody else's? I don't know. I open mine to everybody, but I don't know if Ivana might be having one. You might ask her. I don't know if she's having one or not. This is my last one because I can't do one tonight. Sorry. Okay. So anyway, you let f of x equal this. For the integral test to work, we need to say that, okay, obviously f of n or f of k equals ak for all k. That's clear because the formulas are the same. Okay, awesome. So Taylor in chat is saying Ivana is having one at 2:30 and at 5. Let me, real quick before we finish this, let me text them and see if their review sessions are open to everybody. And then hopefully I'll have an answer for that. Because if you want to go to another review session, that would be fine. And if my mouse will work. Okay, there we go. Okay, so I just texted Ivana and Adam. I know they are holding review sessions. I just don't know if they're opening it to everybody, but if they are, then I'll give you guys the information before this is over. All right, so anyway, to do the integral test, you've got f of x equals this, and f of k then equals a sub k for all k, because they're the same formula. And then f has to be continuous, positive, and decreasing. So f is continuous on 1 to infinity, which is the k equals 1 to infinity part. F of x is greater than 0 on 1 to infinity, and you need to check that that's true, but you probably don't need to give much explanation as to why. X squared plus 1 is always positive, and then x is not, but it is on 1 to infinity. And then f is decreasing is the one that requires some work. And so we're going to go ahead and say it. And then the way we prove it is we say f prime of x, and we try to prove that the derivative is negative. Derivative is the quotient rule, so it's derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Well, that's x squared plus 1 minus 2x squared over x squared plus 1 squared. That's negative x squared plus 1 over x squared plus 1 squared. That's less than 0 on 1 to infinity. And we'll say less than or equal to 0 on 1 to infinity because the bottom is always positive, it's squared. And then negative x squared is going to be bigger than 1. Well, it's going to, x squared is going to be bigger than 1 for anything bigger than 1. At 1, it'll be 0, which is why I put the equals in. But that proves that it's decreasing on 1 to infinity. And then now we do the integral. So these are the 5 things you need to show. So you need to show they're equal. You need to show it's continuous, positive, and decreasing. If those 4 things are all true, then you get to do an improper integral. And if the improper integral converges, then the series converges. And if it diverges, then the series diverges. And so you do the integral from whatever this is to infinity. So here, 1 to infinity of x over x squared plus 1. That is the limit as r approaches infinity of the integral from 1 to r of x over x squared plus 1. The integral of that is 1/2 log of the absolute value, although you could drop that, of x squared plus 1 from 1 to r. So we plug in r squared plus 1 and we plug in 1. And now as r goes to infinity, that r squared plus 1 goes to infinity. Natural log of infinity is infinity. 1/2 of infinity is infinity. And infinity minus 1/2 log 2 is infinity. So this diverges. So because the integral diverges, then the series diverges. So we say, so the sum k over k squared plus 1 diverges by the integral test. Questions on that?
So if you didn't have to do the integral test, wouldn't that just be a k-term test?
It wouldn't be k-term test because the sequence goes to 0, but it'd be one where you compare it to k over k squared.
Gotcha.
And then you use limit comparison test. And then somebody's saying, can I explain why it diverges some more? Sure. So if you look at the infinity, or the limit as r goes to infinity here, infinity squared plus 1 is infinity. Natural log of infinity is infinity, and we know that because the natural log graph looks like that. So it goes to infinity on the right. And then 1/2 of that is still infinity, and infinity minus a constant is infinity. So the fact that you get infinity means that the integral diverges. And then if this is the diverge you meant, what the integral test says is if the integral diverges, the series diverges. If the integral converges, the series also converges, not to necessarily the same number, but they do both converge or both diverge. Does that answer the question that's in chat about that? Okay, cool. Other questions so far? Other questions on this example? Okay. Okay, so the next question is ways to tell what to do. And so I want to show you guys this handout. If you're in my class, you've definitely been working with this handout. If you're in somebody else's class and you don't have this handout but would like it, I'm happy to send it to you right after the review session. Yeah, and so Zach in chat, you're saying, can you compare to 1 over k and make it a p series? Yeah, so you would say p series or harmonic and then a comparison test, unless the problem tells you to do integral test. But yeah, if this is the normal problem, you should not use the integral test unless you're told to. Does that make sense? Yeah, like most of the time, you're not going to be doing the integral test unless you're told to do it. Okay, yeah, like there are very few examples where you would need to use the integral test as far as the problems we're doing. There are very few problems where you'd want to use the integral test. Okay, so let me pull this sheet up and I'll show it to you guys. It's in our shared drive. You guys have seen it in my class a bunch. I know we've got some people in other classes, so I just want to show them. This is kind of the way I think is a good way to think about series. It doesn't, like I said, it doesn't make everything easy all of a sudden, but I think it's the best way to think about stuff. So, and am I sharing the right thing? Yeah. Am I sharing the right thing? Is it showing that sheet? I think it is. Okay. So yeah, so let me move it over here because I cannot see it. All right, there we go. Okay, so this is kind of just the overview of how to talk about series. So if we zoom out just a little bit and see the whole thing. Okay, so at the bottom of this, you've got the ratio test, the root test, and the integral test. Those are kind of standalone. The primary times that you're going to use the ratio test is when you have all multiplication and division, when you have factorials, and or when you have exponentials where the base is not just -1 or 1. So like you can have -1 to the k, but like having another exponential like 2 to the k or -5 to the k or e to the k, that is a good indicator that you might use the ratio test. Having factorials is a good indicator of that, and having all multiplication and division. The key with the ratio test is that you need the limit to work out not to be 1. Okay, so we need the limit to work out not to be 1 on the ratio test. On the root test, the only time you would want to use it is if it's easy to take the k root. That is almost always only when everything is to the k power, or when you can rewrite it so that everything is to the k power. And a key indicator is that k is in the base and the exponent of the same thing. So if you have k to the k, a lot of times that's going to indicate root test. All right, so those are kind of standalone. It's when you're mixing function types and when you have kind of those guidelines that I'm talking about. The integral test is kind of a last resort. We would not want to use it in most cases. Now, the ones above this, if you're talking about alternating series, you kind of start in this box and work backward, okay? So if you're talking about an alternating series, and the types of series I'm talking about are ones where it's -1 to the k, and then everything else is the same function type. So either all power functions or all exponential functions. Then you start here and you say, okay, first you test the absolute value of ak. You then get a series. When you take the absolute value, you're going to get a series with all positive terms. That's where you get an easier series where you take the biggest thing over the biggest thing, and that is either a geometric or a p-series most of the time. The exception is when it's the k-term test. And so you kind of develop these series in reverse order, and then you prove them from top down. So you're going to get, in most cases, a geometric or p-series. That series will either converge or diverge, depending on the rule. Then you go to the one that was harder, and that one is going to do the same thing that this one did. So if the geometric or p-series converges, the one here, the absolute value, converges as well. If this geometric or p-series diverges, then this one diverges. And this is the guidelines for when to use direct versus limit comparison. But in both cases, they both converge or both diverge. If those two converge, then the absolute convergence theorem says that the original one converges absolutely. If these both diverge, then as long as the limit is 0, then the alternating series test says that the series converges, and it'll converge conditionally if that diverged, converge conditionally by alternating series test. The exception is k-term test, which is saying the sequence goes to 0, and that's kind of, that automatically means the series diverges. Like I said, this doesn't automatically make it easy, but kind of let's look at how that works in an example. But that, I would recommend printing that sheet out or copying that sheet down, because you can't use the you're not allowed to use the electronic version, but you can print it out if you would like to do that. So let's look at an example where we kind of go through that process, maybe not show every detail, but go through that thought process. So if you have this problem, I don't know what this color is, but all right. So if we have the sum k equals, say, 2 to infinity of -1 to the k, square root of k, over 3k plus 7. So this is the type of problem where you've got an alternating series and everything is a power function. So square root of k is k to the 1/2, and then this is k to the first, and this is k to the 0. And I am going to try to put that. Somebody just asked, could I send it to them? I'm going to try to put it in the chat and see if you guys can get it that way. Let me do this problem, and I'll try to put it in the chat here at the end. Okay, so this, you're going to start by considering the absolute value. So we go over here. The absolute value is the sum square root k over 3k plus 7. And you're going to compare that to the sum square root k over 3k. Which gets you 1/3 times the sum k, 1 over k to the 1/2. Okay, so this is what the 3 blocks on that series test sheet are trying to tell you, is now you're at the top of the thing. So get to that real quick. You're at the top of the thing where we have a p series. So that the p series that we've got diverges. Then the comparison test is going to show this middle one diverges. And the alternating series test is going to show that this one converges conditionally by the alternating series test. And so all right, so we're over here. So the options are, this will converge. I'm sorry, this one will diverge. That's what's happening here. So we'll do that one first. So this can diverge. And in general, this is going to be p series or geometric. In this case, it's p series and it diverges. Then in here, these two are always the same. Okay? So if this diverges, this one does too. If this converges, this one does too. That is going to be by one of the comparison tests, depending on which one's bigger, or in most cases, you could just default to the limit comparison test. Okay? But either way, if this diverges, this is going to diverge. If this converges, this is going to converge. Then you go back, and as long as the sequence here goes to 0, meaning the non-alternating part, the square root of k over 3k, that goes to 0, then this is going to converge conditionally. By the alternating series test, okay? Because the absolute value diverged, the sequence went to 0. So square root of k over 3k, that goes to 0. What if this sequence did not go to 0? So what if it was like k over 3k? What do you think would happen? If it wasn't square root, if this was just k over 3k, then when you get over here, you get 1/3, which is weird. And so the third case, yeah. And so if it's weird, like instead of 1 over k to the 1/2, you get k over 3k, which is 1/3, or like k to the 5th over k squared, which is k to the 3rd. Whoops, sorry, I'm hitting the page up thing. Okay, so if those are weird, then this should be k term. And so if that happens, the whole thing diverges. All 3 would diverge, but you don't need to do the 3 parts. So if it's weird, then it diverges. The other case is that this one converges by p series or geometric. So, okay, if you get over here and instead of 1 over k to the 1/2, it's 1 over k to the 3rd, then it converges. Well, then this one's the same, always. And this will be by one of the direct or limit comparison. But then if the absolute value converges, the original series converges too, So this converges absolutely. By the absolute convergence theorem. So this is the pattern for a lot of our problems. Okay, a lot. Not every single problem, but a lot of them. So if you have, so this works when you have -1 to the k and then power functions over power functions, like this problem. Or if you have -1 to the k and you have exponential functions over exponential functions, like 2 to the k, 3 to the k, e to the k. That's when over here it's geometric instead. If it's not alternating, if it's just power over power, or exponential over exponential, which is what most of ours are, then it's just the 2 on the right. You don't go back to this because it's not alternating. So these will always do the same, and it's going to be by one of the direct limit comparison, unless it's weird, in which it's the k-term test. Now, the person who asked, is there an easy way to tell? That is the general overview. It's not all of a sudden easy for all of them, but that's the idea. Does that make some sense on how to do that? Okay. I am going to try to send this file over the chat, and if not, if that doesn't work, then we will just wait up if you're in a different class and you don't have this. If you're in my class, that file is in the Unit 3 folder, in which case would the original diverge. So that would be if the sequence did not go to 0. So like if you had this one, if you had the sum -1 to the k over the square root of 9k squared plus 1, then you may not notice at first that that diverges, but by the time you get to the one way over here, it's k over the square root of 9k squared, and that's 1/3. You should notice that that is weird. That's what I mean by it being weird. Does that make sense, Zach? And so you would scrap everything and do k-term test. Okay. On how do we use the k-term test on k to the 3rd? Not sure what you mean. Oh, this. So, okay, like, so if you had, well, if you had this, then it would be a weird type where you'd get k to the 3rd. So the k-term test question would say, okay, well, by the time I got over here, I'd be getting this, right? This k to the 3rd. So I would say, okay, the limit as k approaches infinity of the absolute value of ak is equal to the limit as k goes to infinity of k to the 4th over the square root of 9k squared plus 1. So it would look like this. Does that make sense? Okay. All right. All right, cool, cool, cool. All right, and you should see some examples like that on old exams and on like series 4, especially. There's some problems like that, but definitely pull old exam 3 and exam 4 from previous semesters, and you should see a lot of examples like that. All right, give me 1 second. We're gonna try to get this file shared in the shared drive. Or I'm sorry, in the chat. Man, I don't want to do it. Okay, let's try it this way. Sorry, it won't just let me drag it in. I don't know why it won't, but here it goes. Okay, so it should, if you were in chat, oh, my bad. It went just to one person, my fault. Try one more time. So now if you do need that file, it is now in chat. So go in chat. You can download the series test summary if you don't have it. All right, guys, I've got to stop because I've got something coming up here in just a few minutes. That is it for today. Ivana is having a review session. Somebody's saying at 2:30 and 5. And then I know Adam's doing one at 6. So if you're in their classes, you can definitely go. If you're not in their classes, if you're in my class, I will try to get you their Zoom information. They haven't responded to my text yet. If they're opening it to everybody, I'll email it to you guys as soon as I have it. If not, definitely use the old review stuff, the old exams to review. You've got several years of exams with solutions available, and you've got the practice test with solutions. All right. Any last minute questions? Yeah, no problem. Good luck, you guys. I will shoot an email. You'll get an email like automatically tonight around midnight, kind of with the rules for the test and all that, like you always do. But that should be about it. All right. Yeah, no problem, you guys. Good luck on it, and I will see you later. Thanks for coming, you guys.